Welcome back to Designing AI-Driven Personalized Learning Environments course. This is week 4. In this week, we'll talk about other learner model, that is Bayesian network. In last week, we saw the learner model like item response theory, overlay model. I think this week we'll introduce a new network model, that is Bayesian network or Bayesian knowledge tracing model. Before we go to Bayesian knowledge tracing model, the knowledge tracing means you have to trace the skills over the period of time. We will see what is Bayesian network is, then what is dynamic Bayesian network, how the values are being changed in the Bayesian network. Then we will see how it can be applied to the educational context, how the BKT is born. Then we will see the limitations of BKT. That would end the complete idea of a learner model. But these two models are kind of known and existing, but this is not the only way we have to store the learner data, the only way to trace the learner skills. So let's start with the Bayesian network in this video. So before we go to Bayesian network, we'll start with the very basic introduction to Bayes' theorem. I think most of you know what is Bayes' theorem. It is related to conditional probability of two events which is occurring each other, right? So one event occurred, what would be the probability of other event would be occurring? That's all. It's like, for example, passing a score if I study the exam. It is not necessary that if you study all the time you will pass the score, but there will be a probability that what is the probability I will pass the score given I studied for 8 hours or 10 hours, given I studied. Here the study can be, probability of study can be the value 0 to 1. So to do that, we will use a simple Bayes theorem. The Bayes theorem gives the probability of A given B, that is passing given the study, is probability of study given the pass into probability of passing rate in general, then total or overall probability of study rates, how much you study. So this is very simple Bayes theorem, and we will not go detail how and why, but this will be useful later when we use the Bayesian knowledge tracing models. Now let's go to the Bayesian network. In IIT, that is in item response theory, we measure the student's knowledge using set of questions. The questions would say yes, the student understood the topic or not understood the topic. It is always kind of binary, we see that, and it assumes that 100% certainty. For example, the student answered the question, which means he knows the concept. He did not answer, he don't know the concept. There's no in between. There's no that student is might have made a mistake, or student might have guessed the answer, student might have given yes knowing that you don't know the answer. We can't have a any in between value. Whatever student response is just 100% certainty that he knows the concept or don't know the concept. But in education it is not the case. In education we rarely have 100% certainty. Students might guess, they have typos, they will change the focus in the middle of the learning, they try their new motivation comes up, a new interest, a new topic comes up. Lot of things happen in education. So it's not certain that if a student answers the question, he is always correct. But there are other chances of student might be answering correctly, other chances of student might be missing. Those things are missed in the item response theory. So those things we can consider in the Bayesian knowledge tracing. So what is Bayesian network? It's a probabilistic graphical model that represents set of variables, the variables in the terms of nodes, the dependencies in terms of edges. It allows to system to mathematically understand the connection or the relation between these two nodes and try to observe the things which is not known to the learner. For example, this is set of variables. Variables can be A, and variables become a nodes. The conditional dependency A influences or A impacts B. So that conditional dependency becomes edges. So why we have to put this relationship between the variables as a knowledge graph or this Bayesian network? It's so that it allows you to come up with the mathematical probability, though we can use it to understand how these two nodes impact and how these observable nodes, that is A impacts B. B can be hidden. You can say that We know B because we given A and given these values, B would be this value. So we can use that. That's why it's used Bayesian networks. So it's observable nodes, the test scores, clicks, something like that. Suppose if we have observable nodes, we might have hidden nodes also possible, which is not possible, but we could say that these nodes might mean student have skills, student might learn something, student might have mastered something, those kind of values. So nodes and the edges. The edges represent the influence or characteristics or causality between A and B, what impacts, what is influences. And another thing is it is directed acyclic graph, which means it is directed in one particular direction. For example, here it is directed here. It is directed, which means the it's from one node to the other node. There is no loop back, and there's no loop back in this node to this node also, the third node to first node. So no cyclic, only directed graph. So Bayesian network is a directed acyclic graph. It is represented using nodes and edges. Nodes means variables. It can contain both observable and non-observable variables. Edges might tell you the relationship between these nodes. Okay, I hope it is clear what is Bayesian network. So the compact representation of joint probability distribution among set of random variables and the conditional dependencies is called Bayesian network. This is a proper definition. Here we know it is the distribution among set of random variables and the conditional dependencies. We saw that it is a dependency between distribution of set of random variables, that is the nodes and the dependencies. And we also saw it is a directed acyclic graph. What is compact here? We have to think about it. What is a compact joint representation? Then to understand that, we need to know what is conditional probability table. We'll go deeper one more step. Let's see in this basic understanding Bayesian network. I've just made up some Bayesian network here. Suppose the class at 2 p.m. Okay, the class is at say 3 p.m. A student had a lunch at 1 p.m. and from 2 you thought of he slept. Okay, if he slept and it's not getting up, not getting the reply, you might have missed the class. Okay, this is a possibility. Okay, let's say some other variable, that is have meeting. The student might have a meeting at 3 p.m. Okay, the class is also at 3 p.m. Okay, if the student had a meeting, he has also a chance to miss the class. Okay, given this particular scenario, don't there's a chance that there's a relationship, but given this scenario, consider these two have absolutely no connection. Both are independent events. For example, I decide to sleep one day, irrespective if I have a meeting or not. Decide to sleep is different, and I have a meeting, something is different. But these two are now connected by one event called missing the class. If I know a student missed the class and I know student is not sleeping, there's a high probability student is having meeting. If I know student missed the class and student is not having any meeting in this time in his calendar, there's high probability the student might be sleeping. This is how these conditionally these two independent events are related by this another node. Okay, now these would lead to another event, that is, if I miss my class at 3 p.m. I'm not able to attend the class, the lecturer might have uploaded the videos in some other place, then I can watch the videos or in the Moodle, or maybe read the slides or talk to friends. So watch video lectures, something like that. If I miss the class, I might watch the videos. Now you see there is a nodes, we started giving the variables, that is sleeping is yes, meeting M. This is about missing the class. Okay, missing the class, don't worry, it's attending class or missing, it's missing the class, then video lectures, watching V. Now this is a directed acyclic graph. It is a static direction, there's one particular direction, the cycles are not allowed. And nodes, similarly node S and M are independent, they are not dependent initially, but if the value of C, not C, is known, the dependency on S and M will increase. Okay, that's so the conditional dependency of S and M is coming because of the node C not. There's a conditional independence also occurs between node S and P. Okay, for example, example, if student is the VA and sleeping and watching video is not really important, but if he sleeps, the student might miss a class, then there might be a chance that he must watch a video. So dependency occurs because of the intermediate node. So think about what are the other conditional independent is will be available. That's for the homework, not for the today's lecture. So thank you. We just talked about what is Bayesian network, which is the nodes, set of random nodes distributed, and the dependency shown in a directed acyclic graph. What is this conditional probability table? Then we'll discuss in next videos.